All right, guys, so I'm going to go over this whole packet. I'm probably going to break this into a couple of videos, maybe 3 videos. But the way you're going to work this is you're going to pause, fast forward, rewind to whatever ones you need to go to. I'm going to go over all the problems. So the first video will probably be finding side lengths. Second video will probably be finding angle measures. And the third video will probably be this angle of elevation and depression. I may cut it to 2 videos. But this week's quiz is only going to be on side lengths and angle measures. Okay, and then we'll work more next week on the elevation and depression, and we'll have a quiz on that next week. So these 2 pages are going to be the next 2 weeks because it's applying what you learned about sine, cosine, and tangent. So let's go into this. So first objective is we're going to find a missing side length of a right triangle using a trig ratio when you're given one angle and the measure of one side. So let's look at this. So look at number 1 has a triangle. It's a right triangle with 64 degrees as one of the acute angles. 25 units long is the hypotenuse, and then this side is x units long. So the way you set this up is you try to figure out what information did they give you. They gave you this angle, they gave you this side, and they gave you the hypotenuse. Okay, so if we remember, sine is opposite side over hypotenuse. Cosine is adjacent side over hypotenuse, and adjacent just means next to. And tangent is opposite over adjacent. Okay, so we got to look and see what sides do we have. Well, we have a hypotenuse, so that means we're not going to be doing tangent. And so what side do we have in relation to the 64 degrees? Well, we have the side that is opposite. So x is the side that is opposite the 64-degree angle. So what's that one? That would be sine. So what we're going to do is we're going to say the sine of the angle we're talking about, which is 64 degrees, equals opposite, right? The opposite side, which is x, over the hypotenuse, which is 25. Okay, so we just used the ratio, the trig ratio, to set up this equation. And so now how do we solve this? Well, x is being divided by 25, so what's the opposite of dividing by 25? Multiplying by 25. So we do the opposite to that side, so we multiply that side by 25 and this side by 25. So these cancel out. So x equals the sine of 64 degrees times 25. So look at your calculator. Make sure, all calculators are different, but make sure that your calculator is in degrees and not radians. I don't know if some of your calculators says RAD and DEG. Make sure it's in DEG because you're dealing with degrees. We'll talk about what radians are in the next couple of weeks. So if it's in degrees, then you just type into your calculator 25 times the sine of 64 and hit enter, and we get 22.469. So I'm just going to say 22.5. Okay, and that's how we find the side length using the trig ratio. The first thing you do is you figure out what information they gave you. Or do you have the opposite side? Do you have the adjacent side? Do you have hypotenuse? Whichever two they give you, that's the trig ratio you're going to use, either sine, cosine, or tangent. And then you just set up the equation and solve. Use your calculator to solve. Okay, so let's go on to number 2. So if we look at number 2, we have 47 degrees. That's always our focus. We always focus on the angle they give us. And then we see what sides they give us in relation to that angle. So if we look here, here's the right angle. The hypotenuse is always opposite the right angle. So this is the hypotenuse. The longest side is always a hypotenuse. So that means these other 2 sides are the legs. One of them's adjacent to the angle. One of them's opposite of the angle. So let's look. Over here, that is the opposite side of 47 degrees. And 12 is the adjacent side because it's right next to the angle, because that's the angle we're focusing on. So which trig ratio has opposite and adjacent? That's tangent, isn't it? So that's what we're going to do. We're going to set this up by saying the tangent of our angle, which is 47 degrees, equals the opposite, which is x, over the adjacent, which is 12. And so how do we solve this? Just like we did last time, let's get the x by itself. So what's the opposite of dividing by 12? Multiplying by 12. And we do that to both sides. 12's cancel. So x equals 12 times the tangent of 47. Again, just plug that into your calculator. 12 times tan 47, making sure your calculator is in degrees, or DEG. And then hit enter. And you have 12.868. We'll just say 12.9. Okay. Again, in this video, pause when you want to do a problem and then see if you got it right. Fast forward if you get these problems and you want to go to one that you don't know. And if this is confusing at all, make sure you send me a question on Remind. Please send me questions on Remind. I'll answer anything you have. Okay. So let's go to number 3. So here's our angle that we're focused on. This side over here, that's opposite of 90 degrees, is my hypotenuse. Okay, we don't care about this side because there's nothing there. So we do care about this side where the x is. So this side is what to 18 degrees? Is it across from it, or opposite of the angle, or is it next to, adjacent? And if we look, it's adjacent, it's next to. So this is the adjacent side. So which trig ratio has adjacent and hypotenuse? Yes, cosine. Cosine is adjacent, over hypotenuse. And so the cosine, we always find the cosine of an angle, right? These trig ratios are always about in relationship to angles. So sine, cosine, and tangent of an angle equals a ratio of sides. So the cosine of the angle, which is 18 degrees, equals the adjacent side, which is x, over the hypotenuse, which is 34. And so to solve this, let's get x by itself. So it's the opposite of dividing by 34 is multiplying by 34. So we cross that out. So x equals, again, 34 times cosine 18. Put that into your calculator. 34 times cosine of 18 degrees. Make sure your calculator is in degree mode. And you get 32.33, which is just 32.3. Okay, any questions? Send them to me on Remind. Or you can put them in the comments here. All right, number 4. Here's our angle. We have the opposite side, which is 9, and we also have the adjacent side. And don't forget, how do we know that those are the legs, those are the opposite and adjacent? We know that because here's my right angle. The side opposite the right angle is always the hypotenuse. Opposite and adjacent sides are only the legs. Hypotenuse could never be an adjacent side. The hypotenuse is the hypotenuse. So we don't have the hypotenuse, so we're not even worried about that. So which trig ratio deals with the opposite and the adjacent? That's right, it's tangent. The tangent is opposite over adjacent. So now let's fill in what we know. The tangent of our angle that we're interested in, which is 35 degrees, equals the opposite, which is 9, over the adjacent, which is x. And now we solve. So this one's a little tricky. Some of you are looking at this going, wait a second, the x is on the bottom now. Do I multiply by 9? No. The x is on the bottom, so the only way to get x out of the bottom is I'm going to multiply both sides by x. Okay? And that'll cancel the x here, but it'll put it on the other side. So now we have x times the tangent of 35 degrees equals 9. And so now since x is being multiplied to the tangent of 35, I'm going to divide both sides by the tangent of 35 degrees, and they will cancel. So x will equal 9 divided by tangent of 35 degrees, and then you can plug that into your calculator. 9 divided by tan 35, and make sure it's in degrees. Hit enter, and we get 12.85, which is the same thing as 12.9. Okay, so let me recap what we did. We had opposite and adjacent side. We did not have the hypotenuse. So we used the tangent ratio because tangent is opposite over adjacent. Then we plugged in what we knew, tangent of 35 degrees, because that's the angle that they gave us, and that's the angle we're talking about, equals the opposite side, which is 9, over the adjacent side, which is x. And now we have x in the denominator. I don't want the x in the denominator. I want it upstairs in the numerator so I can solve for it. So I multiply both sides by x. So this one cancels. And then I get x times tangent of 35 equals 9. Divide both sides by tangent of 35 so I can get the x by itself. They cancel out. So x equals 9 over tangent of 35 degrees. Punch into my calculator. I get 12.9. Okay. Let's go to number 5. Number 5, here's my angle. And if we look here, there's my right angle. That means this side is the hypotenuse. So that means x is my hypotenuse. And the side that they gave us, one of the legs they gave us, is the opposite side of 63 degrees, the angle we're looking at. So this is the opposite side. So what trig ratio has opposite and hypotenuse? You guessed it, it's sine. Sine is opposite over hypotenuse. And if you forget, don't forget, so, ka, toa, right? Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So, ka, toa. That's what we learned last week in last week's packet. So sine is opposite over hypotenuse. So the sine, and we're talking about 63 degrees, equals the opposite, which is 27, over the hypotenuse, which is x. Now we have our equation. Now let's solve. So again, we have the x in the denominator, so I don't want it in the denominator, so I'm going to multiply both sides by x. So these cancel. And so now I have x times sine of 63 degrees equals 27. And now to get the x by itself, I'm going to divide both sides by the sine of 63 degrees. And that'll get me x equals 27 divided by the sine of 63. So I'm going to punch that into my calculator. 27 divided by sine of 63 degrees, making sure your calculator is in degree mode. And we get 30.30, which is just 30.3. And there you go. Okay, number 6. So we have 30 degrees. We have x is our hypotenuse. Okay, so 30 degrees, and we have our hypotenuse. Now 18, is that the side that is adjacent to 30 degrees, or is it opposite of the 30 degree angle? That's right, it's adjacent. It's next to. Okay, so now which one has adjacent and hypotenuse? That's cosine. So cosine is adjacent over hypotenuse. So let's set up our equation. The cosine of 30 degrees, because that's the angle we're interested in, equals the adjacent side is 18 over the hypotenuse, which is x. Again, we don't like the x in the denominator, so I'm going to multiply both sides by x. So these cancel, and we get x times cosine of 30 degrees equals 18. I'm going to divide both sides by the cosine of 30 degrees, cosine of 30 degrees. So x is going to equal 18 divided by cosine of 30 degrees. And we get 20.78, which is just 20.8 if we round up. All right, guys, those are the 6 problems of finding side lengths. If you have any questions, please send them to me on Remind or put them in the comments here. And remember, to get credit for your notes for this week, you have to put in the comments that you saw the video. Put your name there if your YouTube name doesn't match you, just so I can identify you, and I'll give you credit for taking notes for this. Okay, I'm going to make another video for finding angle measures, and I'll make another video for elevation and depression, so look out for those. They will be in this same playlist. And if you have any questions, again, send them on Remind.